We are in week 7, I think it is now, in our Science and the Bible course. This is a course that is produced by the Theology Program, which is a ministry of Reclaiming the Mind Ministries. Most of you here I recognize from previous weeks, so I'm glad to see you here again. And yes, we are recording this. Tonight we're going to begin the final third of this course, focusing now on the science, focusing on the scientific issues that pertain to this whole controversy over origins and the relationship between science and theology, science and the Bible. And tonight we're going to look at cosmology and physical science as they relate to these controversial issues. Next week we'll get into the biological sciences and the whole issue of creation evolution. But tonight we're going to talk about the scientific evidence for two claims that are basic to the Christian worldview. The first claim is that the universe had a beginning, that the universe is not self-existent or eternal, but that it depends for its existence on something else that would then have to be ultimately something that is self-existent and eternal. So that's the first claim, that the universe had a beginning, that it is something that originated in some fashion. The second claim that is basic to the Christian worldview that we're going to talk about tonight is the claim that the universe exhibits purpose, or as it is often called, design. That is, that the universe does not appear to be a completely random happenstance, a completely random set of events that have and things that have no purpose or no function or no value, but that in fact the universe has value because there appears to be evidence in the universe of some kind of intentionality in the way the universe is, that things are the way they are for some kind of reason. Now, I'm putting this in very general terms, and of course the Christian would put this in a much more theologically specific way. The Christian would say simply that God created the universe, and that He created the universe for the purpose of inhabiting it with His creatures, specifically human beings and the other creatures that live here on the earth, and if there are creatures elsewhere, those as well. But the idea is that the universe is created, and created with a purpose in mind, that it was designed as a habitation for creatures by God. Now, it used to be, not very long ago, that science was claiming that either they had disproved these basic claims of the Christian worldview, or that they had rendered them archaic and without any kind of evidence to support them. It used to be that Christians were on the defensive, really, on these issues, because it seemed to be harder and harder to make the case for these two claims. Well, if you probably are familiar with this somewhat, but if you're not, I have good news for you. If you're a Christian, the situation has changed dramatically, and there is now abundant evidence to support this perspective, these two claims about the world and its nature. And it is the non-theist, the non-believer in a creator God, who is on the defensive. And that is a dramatic turnaround, and it's happened in a generation, although the seeds for it go back to the beginning of the 20th century. So I want to give you a little bit of the history of how that came about, And in doing that, just sort of rehearsing, where we've come and how we got here to this particular point, shed some light on these two claims and why science now appears to be vindicating these two claims in very dramatic fashion. The place to begin really is with the beginning of the 20th century and the revolution in cosmology that was the leading figure of which was Albert Einstein. You've all heard of Albert Einstein. You've all heard of E equals mc squared. You've all heard that Einstein had something to do with the theory of relativity. What you may not know is that Einstein's theories and his equations had some implications for our view of the nature of the cosmos that surprised, shocked, and in some cases upset astronomers and other scientists in the early 20th century. What happened was a particular astronomer, a Dutch astronomer named Willem de Sitter, studied Einstein's equations and worked out from them mathematically that the universe was expanding. Now, de Sitter was kind of the Copernicus of this revolution. Copernicus, if you remember, if I may draw an analogy here, Copernicus was the Polish astronomer, mathematician, and priest, by the way, who worked out using mathematics that a more elegant solution to the issue of the movement of the planets and the other heavenly bodies was that the Earth revolved around the sun rather than the sun revolving around the Earth. But Copernicus basically had nothing but math to back him up on that. In other words, he had a brilliant mathematical model that made that appear to be a better explanation for the astronomical data, but he didn't actually have physical proof that the Earth revolved around the sun. And that the planets, by the way, also revolved around the sun. Copernicus argued that his mathematical model provided an elegantly simple demonstration or way of thinking about the movement of the heavenly bodies and of the Earth, that the planets and the Earth all revolved around the sun. But he didn't have any way of physically proving that. Flash forward a generation, and Galileo turns his telescope on the heavenly bodies and finds physical evidence to corroborate Copernicus's mathematical model. And by the way, today is the 400th anniversary of that particular auspicious event in which Galileo took his telescope and started looking up into the sky using the telescope. That was 400 years ago today. So now drawing my analogy here, comparison, de Sitter had a mathematical proof that the universe was expanding. And it's interesting, the reversal in in the history here. In Copernicus's day, Copernicus was the mathematician who was upsetting the church with his theory that the Earth revolved around the sun. In the beginning of the 20th century, de Sitter was upsetting the scientists, the agnostics, the scientific establishment, because he was arguing that the universe was expanding, and they all saw immediately the implications of that as being hostile to their worldview, which was that the universe has always been here. It's always basically been like it is now. And by the way, if you want to hold to an eternal universe, you pretty much have to hold that it's always been the way it is. Because if it's been radically different than it is now, we should have been done with whatever the universe was going to do. So, I'll be more specific about what I mean by that as we go along, but the point is that the astronomers and cosmologists of De Sitter's day, that were agnostic, and many of them were agnostic or atheist, didn't like what De Sitter was arguing because it conflicted with their worldview, not because they had rational reasons to object to it. But as long as it was just a mathematical model, they could react to it and dismiss it the same way the church dismissed Copernicus's mathematical model of the Earth revolving around the sun. Well, then along came scientists who started finding physical evidence to back up what De Sitter had said. Edwin Hubble. Now, we've all heard of the Hubble telescope, right? Well, it was named after this astronomer of the early 20th century named Edwin Hubble. And he had his own little telescope compared to what we call the Hubble. It was little. It was a 100-inch telescope, which was huge for those days, of course. Huge telescope. Much, much bigger than anything Galileo could have dreamed of constructing. And Hubble used his 100-inch telescope to verify De Sitter's mathematical model in some very important respects. And specifically, what Hubble discovered was, what he was able to observe was that the farther away a galaxy is, the faster it is moving relative to our position. I'll repeat that because that may have just gone right by you, like a galaxy moving past you quickly, all right? What De Sitter had predicted mathematically, but couldn't prove physically, just his mathematical model predicted that this was the case, that the farther away a galaxy is, the faster it is moving away from us relative to our position. Well, Hubble had this 100-inch telescope. He was able to look at galaxies and stars that were far away from us, and the galaxies that were further away from us than the quote-unquote nearby galaxies were indeed moving away from us faster than the nearby galaxies. Of course, a nearby galaxy is very far away, but relatively speaking. And so what De Sitter's mathematical model had predicted as an element of this idea that the universe was expanding, Hubble was able to watch, was able to observe, and physically document by looking at these galaxies. Now, you might want to know, what was it that, how does Hubble do that? I mean, did he sit there with his 100-inch telescope and watch the galaxies for years and sort of clock their movement? No, obviously he couldn't do that. What he did was, what you could do is you can observe the red shifting effect of these galaxies' movements. Red shifting concept is actually easier to explain in using the analogy of sound than it is light. Many people will understand this a little bit easier. If you've ever been standing very near a train, you may have noticed that as the train approaches you, the pitch, the note, as it were, that the train's movement makes as it approaches you begins to go up. It's not just that it gets louder, the pitch gets higher. And then as the train moves away from you, it starts to go down. It goes down. All right? That's not a very good imitation of a train sound, but the noise that the train makes is a kind of has a musical pitch associated with it, and that pitch goes down as the train moves away. Somebody here knows what this is called. It's called the Doppler Effect. Well, that is analogous to what happens as galaxies move away from us. They shift down in their light that is moving toward us, is moved further toward the red end of the spectrum, the farther away the galaxy is, the more this redshift effect is evident. Just like as the further away the train is, the lower the pitch that it seems to be emitting to you relative to your position. Obviously, and this is the thing that is confusing about this, perhaps, if you think about this, if you're standing at a train station and somebody else is standing at another train station a mile down the track, as the pitch that you hear goes down, the pitch that the person at the train station a mile down, as the train approaches him, goes up. Now, just think about that for a second, because, in other words, it's not, the pitch that you're hearing is not an absolute pitch that everybody hears the same at the same time, no matter where they are. It depends on where you are. And that's what the redshift effect that we're talking about is like. That's what the Doppler effect is. And, of course, this has to do with Einstein's concept of relativity, that these motions create different effects depending on where you are. They look differently when you look at them through a telescope. Well, as I said, Hubble was able to look through his 100-inch telescope and notice that the further away a galaxy was, the more the light from its stars or whatever was in that galaxy was redshifting relative to our position. Hubble's discovery was not met with joy in the streets and in the laboratories of university scientists all over the world. It was met with unhappiness, distress, and even disgust. One writer puts it this way: Einstein himself was the first to complain. This idea that the universe was expanding had an obvious implication, and that was that it had a beginning. You see, if the universe is expanding in all directions, that implies that it is expanding from some kind of central point from which that expansion begins. That there is some kind of a point zero where the universe begins that expansion. If it's been expanding, it can't have been expanding forever. At least that's the first thing that you think about when you look at this. Now, not that scientists aren't creative and couldn't come up with some ways around it, but that's the natural implication of this discovery that the universe was expanding. And so you had scientists like Arthur Eddington. I remember reading some of his stuff 20, 30 years ago. Of course, he went back a lot further than that, but he was a classic science writer. Eddington, who helped to prove this, he was involved in this too. He admitted that he didn't like the idea. In fact, he found the idea of a beginning of the cosmos repugnant. That was his word. And he hoped that a loophole would be found to avoid the implication of some kind of cosmic supernatural creator or beginner of the cosmos. And that's actually the term he used, a loophole. He was hoping for a loophole. Hubble, and again, this is fascinating, the psychological responses of these scientists to their own discoveries. Hubble spent the rest of his life arguing against the theory that came to be known as the Big Bang Theory. Fred Hoyle actually dubbed it the Big Bang Theory as a label of derision. Many people don't understand this. The term Big Bang, in reference to this idea that the universe had a beginning, was a term used first by a scientist, Fred Hoyle, who didn't like the idea and was trying to make fun of it. And Hoyle rejected the idea as well. And as I said, many scientists started looking for these loopholes that Arthur Eddington had hoped would be discovered. And they floated a number of alternate explanations for the astronomical evidence. And when I was in elementary school, I was taught these alongside the Big Bang as equally possible, equally valid models of the origins of the cosmos. And just to help you out here, I was in elementary school in the early to mid 60s. All right, in the 60s. And so in the 1960s, I specifically remember being taught these different models. In fact, I think they were still being presented this way even into the early 70s, that astronomers, scientists had three explanations for the physical evidence that we could observe, three different models of the universe. And these were the Big Bang Theory, which held that the universe had a beginning that started some finite time ago. That's, in the billions of years ago, but nevertheless had a beginning. The second one was the steady state theory. The steady state theory was the a version of the more traditional cosmological model that the astronomers who were agnostic or atheist liked, but try to accommodate the Big Bang evidence. The steady state theory held that the universe was merely expanding in some places, but not everywhere. In other words, yeah, we can see some expansion going on, but it's only a local or regional phenomenon, not the entire cosmos. Well, then there was a kind of a compromise view that some scientists came up with called the Oscillating Universe theory, and you can still find some diehards holding on to this one, but not the steady state theory. The Oscillating Universe theory holds that the universe is expanding, and did begin with a kind of a bang, or what is called, a technical term for it is a singularity, where it starts from nothing and sort of expands out like a balloon. That the universe expands, slows down, stops its expansion, which it hasn't done yet this particular go-round, then begins to contract again, shrinks down to that point zero, starts blowing back up again, like a balloon, inflating, deflating, and doing it over and over and over and over, somehow on its own steam, indefinitely or infinitely. So that you've got an infinite universe, an eternal universe on the steady state and oscillating universe theories, but a finite temporal universe with the Big Bang theory. Now, the stakes here are extremely high. We cannot underestimate how important this seemed to scientists in the 1960s to prove that the Big Bang theory was wrong. The evidence for it had begun to mount in the 40s and 50s. The more they looked, the more it seemed to verify what Hubble had originally seen, that the universe is expanding. And they couldn't find any part of the universe that wasn't, which is really upsetting if you're a steady state theorist. And it took a while for the implications of this to ripple throughout the astronomical the cosmological community. But right there in the middle of the 60s, a couple of scientists working at a laboratory, Bell telephone scientists, made a discovery accidentally that really killed the steady-state theory. In 1965, Arno Penzias and Robert Wilson made a discovery that shocked the cosmology community. They were cleaning their instruments in this laboratory with a very large telescope and all this stuff. And they discovered that they were getting readings from the different parts of the cosmos that they were looking at through the telescope that were a little bit off of zero. In other words, there was some kind of what seemed to them at first to be some kind of an error, some kind of a mathematical error. And what they found out as they checked their instruments was that it was no error. What was it they were seeing? Well, they were seeing something that had been predicted by the Big Bang model of the universe for decades, but nobody had any evidence of, and I haven't even mentioned yet. And that is what is famously known now as the cosmic background radiation. Now, what is this cosmic background radiation? Well, if the universe had a Big Bang, if it started off with a bang of some sort, it started off with some kind of sudden explosion of light and matter and energy in expanding in all directions, this would generate a great deal of heat. And after the universe had expanded, quadrillions of miles in all directions, there would still be a kind of faint background radiation that you would see everywhere you looked that would be so low that it would be difficult to detect. It'd be like, this isn't a precise analogy, but it's just a kind of an example. After you've used the stove for a couple of hours, and you turn off the stove, there remains a kind of a heat that is radiating from the stove and actually fills the room. And you don't notice it as much after an hour or two, but it's still there. And if you're really sensitive to heat, you might pick up on it even after a good while. Well, the cosmic background radiation is much more subtle than that, and it's almost impossible. It's not possible to notice it with your skin or with the naked eye or with typical instrumentation. It was something that they accidentally stumbled on, these two scientists, in 1965. It seemed to prove exactly what the Big Bang theory, the Big Bang model of the origin of the universe predicted, that there was this sudden explosion of energy and matter in all directions, and that really killed the steady-state theory. And it didn't quite kill the oscillating universe theory, but it put it on life support, if you will, because one of the problems that the oscillating universe theory has is that there is the difficulty of, if you will, the conservation of energy in a process of the universe expanding, contracting again, then expanding again and going back and forth and back and forth. Every time it sort of implodes, you'd lose something in the next bounce, as it were. The oscillating universe imagines the universe sort of bouncing back and forth from nothing to a very large universe and then back down to nothing again and bouncing over and over. And physically, there are some difficulties imagining that happens infinitely. Well, the developments in science did not stand still after this discovery by Penzias and Wilson in 1965. Ironically, right around the same time as, I'm sitting in elementary school being taught that the steady-state theory is a legitimate model, just a few miles away from where I was in Pasadena, California, the scientists were discovering that wasn't the case. Well, by the 1990s, we had really moved beyond what those guys in the 60s could even dream about. We had satellites orbiting the Earth that were able to examine the heavens without having to filter through the atmospheric interference and the dust and so forth in our atmosphere. And we were able to get much more precise pictures of things, much more precise images, and mathematically quantifiable information about the light coming from these different galaxies. And I could go on. I'm trying to keep this somewhat simple, but basically, we had this satellite called the Cosmic Background Explorer, or COBE satellite, that was able to report back some information about this cosmic background radiation. Now, one of the things the scientists wanted to know is how evenly distributed is this radiation. Remember my analogy of the stove. If you're in a room where the stove has been on recently, it'll be a lot warmer near the stove than it is farther away from the stove. And, if you're around the corner from the stove, obviously you won't be as affected by whatever leftover heat there might be than as if you're in a direct line from the stove. Well, it turns out that the cosmic background radiation, if you hold to an oscillating universe theory, you would expect a different set of readings as to how uniformly this radiation is spread throughout the cosmos than if you held to a Big Bang model. And the COBE satellite demonstrated that the universe had begun with what scientists describe as a very hot Big Bang, a very hot explosion from a central point of origin. And this is not what you want if you want oscillating universe. You want a very cool bang, quote unquote, that can be duplicated over and over and over. A very hot Big Bang implies that it only happened one time. Stephen Hawking, and you've all heard of him, I think. Stephen Hawking, who was the famous author of the book A Brief History of Time, he referred to this discovery of the COBE satellite, of this hot background radiation. And this is a quote. This is Stephen Hawking. He called it the discovery of the century, if not of all time. End quote. Now, the reason why he called it that was because it proved that the Big Bang theory was true and that the universe had a beginning. It proved the steady-state theory wrong. It proved the oscillating universe wrong. It really left us only quibbling over which version of the Big Bang theory we were going to hold. Now, this evidence eventually convinced almost all cosmologists and astronomers, not quite all, but almost all of them, to hold to some version of the Big Bang theory. Now, they didn't all immediately become theists or believers in God, but they did come to the reluctant conclusion, in many cases it was quite reluctant, that the universe had a beginning. In fact, Stephen Hawking was one of these individuals who didn't like the theological implications. And much of his book, A Brief History of Time, is really a kind of thought experiment, a kind of what-if scenario that he develops to propose a way of thinking about the universe having this beginning without it implying a beginner. And so, in other words, Stephen Hawking was looking for loopholes. And this is what people have been doing for a century. Arthur Eddington wanted to find loopholes. Albert Einstein introduced a fudge factor kind of, as it was called, into his equations to try to come up with a cosmological way out of the implications of the universe having a beginning. He later retracted it because the evidence was against it. And scientists have been coming up with ad hoc theories to get around the evidence ever since. What is ad hoc? That is a Latin expression which basically means whatever you need to say to get out of the argument you will say. And so an ad hoc explanation is something you kind of make up as you're going along as a way of getting around the evidence that seems to point in the obvious conclusion that your theory is wrong. And so scientists committed to the idea that the universe was eternal have been developing one ad hoc explanation after another for the physical evidence. Once they could no longer get around the fact that the universe had a beginning, these scientists and also philosophers who were committed to atheism began developing ad hoc explanations for how the universe might have had a beginning without having a beginner. In other words, for 2 generations, they were trying desperately to prove the universe didn't have a beginning because they realized that that would strongly indicate a beginner. That was the immediate and obvious conclusion, if the universe had a beginning, that it would have had a beginner. Or at least something that began it, maybe not a personal beginner, but something up to the task of setting off the Big Bang. When they could no longer get around the fact that the universe had a beginning, they began looking for a loophole that would account for the universe having a beginning without having a beginner. And so you have all kinds of very creative and speculative, totally speculative models for how this might have come about. Which, there's almost no point in getting into them because there's no evidence that there was anything that you could describe as physical or as some kind of reality of a what we would consider a created nature that existed before the Big Bang, or that existed in some kind of nether existence that is exterior in some way to our physical universe. I mean, you've got people talking about such things as quantum foam or something, where it doesn't exactly exist and it doesn't exactly not exist, but it's just kind of there eternally, and there's nothing you could say about it very precisely, but somehow out of this quantum foam you get a kind of spontaneous eruption of existence in the formation of our universe. I remember Isaac Asimov, one of the most entertaining science fiction writers of all time, and also one of the most entertaining science writers of all time. Very, very lucid, very compelling descriptions for the layman of different features of science, especially physical science. Asimov actually argued that the universe could have had a beginning that really starts itself, and his analogy or his argument for this was if you have an equal number of pluses and minuses, they cancel out to 0. Well, why couldn't you then start with 0, and from this 0 spontaneously emerge an equal number of pluses and minuses? Now, if you understand that explanation and how that actually accounts for the origin of the universe, let me know. But I think it's just another thought experiment on the part of a non-theist who is desperate to get around the evidence that the universe had a beginning. Now, if the universe had a beginning, then this is very disturbing to scientists who are looking for physical, natural, non-supernatural explanations for everything. You bump into something that has no scientific explanation. And Robert Jastrow, who was a very well thought of astronomer, wrote books on astronomy that were well received, and was himself an agnostic, wrote a classic little book called God and the Astronomers, in which he told the story that I've just told you a little bit differently, but basically he's telling the same story that I've just given you. And at the climax of his book, he has this famous little paragraph. And I'll read this short little paragraph. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. End quote. Now, what Jastrow was saying is, the scientists have been reaching for the pinnacle of knowledge, the explanation of everything, and they thought they were right about there. They were going to have a natural explanation for everything, and just as they got to the ultimate question, why is there something rather than nothing, they ran into the obvious explanation from a theological standpoint, and that is somebody made it. God. No, not that. That's been the reaction. I'll tell you a funny story. This is true. There was one science writer, philosopher of science, who looked at this evidence, and he wrote a paper a number of years ago. I think this is back in the 70s or early 80s. He wrote a paper. It was a very academically sophisticated paper in some ways, in which he argued as follows. Well, folks, it looks like the evidence is in that the universe had a beginning, that there was a Big Bang. Boy, the fundamentalists are hitting us over the head with this. They are crowing that they now have proof the universe had a beginning. And doggone it, they're right. The universe did have a beginning, and somebody must have started it. But we can't go back to believing in Genesis and the fairy tales of the Bible, and a God who would tell us what to do and what not to do. We can't have that. So we need to think about this. Is there some other explanation? Because the fundies are right. The universe had a beginning, and somebody must have done it. So this guy says, we're not the smartest bulbs in the universe, probably. And he says, somewhere in the universe, very likely not in our galaxy, and very likely not even in our eon, perhaps millions of years from now, perhaps in another galaxy. I mean, it would be hubris to think that we, millennia from now, will figure this out. But if not us, probably somebody else in the universe at some time in the history of the cosmos will not only realize that the universe had a beginning and that somebody had to begin it, but of course, being the sophisticated people that they are, or will be, they will know that it can't be God. They will know that there is no God to make the universe, but they will also realize that somebody needs to start the universe. And so, in order to make this happen, they're going to take it upon themselves to do it. And so this super sophisticated advanced society on some planet somewhere in the universe, who knows where and who knows when, will send back in time a time traveler back to point zero of the universe to set off the Big Bang. Now, you must be thinking I'm making this up. Nobody could ever actually submit a paper at a symposium arguing this idea and, with a straight face. Well, I wasn't there, so I don't know if he had a straight face or not, but he seems to have been serious. And the idea here is anything but God. Anything but a creator of the universe. Now, obviously, it's not possible for some futuristic time traveler to travel back in time to start the Big Bang, because if he got to the point of the Big Bang, it would already be happening, and you can't go behind the Big Bang because there is no time before the Big Bang. This is one of the really amazing and shocking and upsetting things about the Big Bang theory. It holds that not only did the physical stuff in the cosmos have a beginning, but that time and space had a beginning. In other words, that there is no time before the beginning of the universe. You don't have an endless, everlasting stream of time, and then somewhere in that stream of time, the universe begins. It's not as if you could go back in time 1 trillion years ago, long before the Big Bang, and sit there and watch the Big Bang happen, because there was no time and there was no space prior to the Big Bang. Physically, there is no prior. There is no time and no space before the Big Bang. Well, that's exactly what you would expect if you were a theist. Not an atheist, but a theist. You would expect that the universe would not have always existed and that time itself would be a function of the cosmos. See, the classical view of God is not that God is merely everlasting in the sense that God has always existed in a linear temporal way and will always continue to exist in a linear temporal way, but that God transcends time, that he is above time, that he is more than, not less than. It's not that God is locked out of our temporal stream. No. But that God transcends the temporal because God made it. And again, that's what we mean in classical Christian theism when we say that God is eternal. We don't just mean he's always been around. Because nothing has always been around in the sense of existing infinitely back into the past in a linear temporal stream moving forward. What we mean is that God has always existed as long as there's ever been anything, and in fact, he transcends the whole shebang, the whole show of space and time. And because he transcends not only time but space, this is what we mean when we say that God is omnipresent and infinite in his being. He isn't just somebody who is able to get around in the cosmos wherever he wants. He is somebody who transcends the very spatial limitations and nature of the cosmos because he made it. And here's the upsetting thing if you're not a theist. The universe fits that model of there being some kind of transcendent supernatural being, something, or someone bringing the universe into existence as a finite spatio-temporal order. That's exactly what the scientific evidence now supports. Exactly what the agnostic and atheist scientists did not want. And by the way, what the pantheists did not want. Because if you're a pantheist, you want the universe to be as eternal as God, because it's God's sort of display of himself. If you're a panentheist, you've got to have the cosmos really be eternal in some sense, because God can't not have a body, and if panentheism is the belief that God's body is the cosmos. Well, if God's body is the cosmos, he hasn't always had one. That's a little bit confusing. So anybody who holds one of these worldviews is able to come up with creative, speculative, ad hoc ways around this, but there's no question now that the evidence for the beginning of the universe is compelling, and that it most naturally, most simply, most directly, and most obviously supports the theistic worldview. Most obviously and naturally supports the belief that there is a God who created the universe out of nothing. We now have evidence not just for creation, but for creation ex nihilo, that the universe came into being out of nothing. This is bad news for Mormonism. I don't know if you're aware of this, but Mormonism denies the idea of creation out of nothing. It teaches that God organized this present universe into its form using eternally pre-existing stuff. Well, that was a viable theory in the 1830s and 1840s when Joseph Smith advocated it. It is not a viable theory now. This is the problem if you want to be a prophet and you want to make speculative statements about the nature of the cosmos. You run into the danger that the scientific evidence will contradict you later down the road. And Joseph Smith got it wrong. The universe was not formed out of eternally pre-existing stuff. It was brought into existence out of nothing. Whatever that means. I mean, admittedly, that's a brain stretcher, but that's what the physical evidence shows. All right, so I've described here the evidence for the first of the two claims, that I described, which at the beginning, which was that the universe had a beginning, implying a beginner. But we're not done. The second claim, which is essential to theism, is that this beginning was not some kind of random fluctuation or accident. The universe it's not a big bang in the sense of some kind of accidental explosion somewhere, but that the universe's beginning was an exquisitely planned event, and that the universe itself shows evidence of planning. Now, this is such a radical claim to many people's minds that, again, scientists have been resisting this particular claim. Many scientists, not all, because again, some scientists are, conservative Bible-believing Christians. But an awful lot of scientists throughout the 20th century opposed this idea on philosophical and methodological grounds. The idea that God creates the universe out of nothing and makes it be a certain way and plans it and it's designed and all that. Well, if you're going to bring God into it, then what is there for us scientists to do? We want to explain everything, and we don't want to have God intervened into this or introduced into this as an explanation, because that short circuits what we think is our proper domain, which is to explain everything that is physically existing in the way that whatever way we can. The problem is that the scientific evidence is now, again, against this idea that the universe just sort of happens to be the way it is. The term, one of the terms that's often used in this connection is that the universe appears to be fine-tuned. Fine-tuned. Now, what do we mean by that? Well, if I go back to the analogy of music, we talked about the sort of musical pitch level that you hear when a train passes you by. Imagine trying to orchestrate things so that when the train passed you by, at a certain point in time, an exact point in time, that it would produce a perfect C note pitch. Well, you would have to, and it had to be at that particular time when you were standing at a particular place. Well, in order to do that, that would require some planning, wouldn't it? Now, of course, if the train rumbles by and you've got people standing all over the place, somebody somewhere is going to hear a perfect C note at some point during the process, maybe not at any particularly interesting point in time or interesting place that they happen to be standing. But, you might get a perfect C pitch for a fleeting second somewhere near the vicinity of the train as it goes by. But no, we're talking about what if you needed to have it be exactly at a particular point in time in a particular physical location that you would hear a perfect C note, and the train had to move by just at the right speed and just at the right time to get that perfect C note. And by golly, you got it. What would you think? Well, you'd think somebody had planned that. That's what you'd think. Well, that's what I mean by fine-tuning, that the universe itself appears to have been fine-tuned. And not just fine-tuned in some kind of, well, it's very precisely this rather than that, but fine-tuned to make it possible for the universe to sustain life somewhere in the cosmos. The universe is, as many people have put it, just right for that to be the case. Now, let me give you some examples of this fine-tuning that I'm talking about. This goes from everything from the basic fundamental elements of the cosmos itself to things having to do specifically with the Earth and our solar system and the physical parameters of the Earth itself and everything in between. I can start just by talking about some of these fundamental physical constants in reality throughout the cosmos. There are such things as these would be such things as the strong nuclear force constant. This is something that you can express mathematically, that the elements, the constituent parts of the nucleus of atoms, the neutrons and protons and so forth, that there is a force that holds these together, and it turns out it has to be fine-tuned, as it were, or just right, in order to have an interesting universe. If the strong nuclear force constant is much greater than it is, and it doesn't have to be a lot greater, just a little greater, you will get no hydrogen. And no hydrogen, no water, no interesting, no stars, nothing interesting at all, and no possibility of physical life in any meaningful sense. If the strong nuclear force constant is lesser, were to be lesser than it is, by a very small margin, you'd get hydrogen, all right. That's all you get. And a universe with nothing but hydrogen would, again, not be a particularly interesting universe, and we wouldn't be here to talk about it. In fact, nothing would be here to talk about it, or even experience it, because all you'd have would be hydrogen. And there are a lot of these. Electromagnetic force. It's got to be basically right where it is. If it's a stronger force than what it actually is, you can't have molecules. And by the way, if it's a little weaker than it actually is, you can't have molecules. The gravitational force constant, basically how strong gravity is, if you will. If it were to be a little bit stronger than it is, big stars, we'd get a lot of big stars that just burn out fast. They would be flash in the pans. Because if the gravitational force is much stronger, you get bigger stars, and the bigger stars tend to blow up fast. If you have a slightly weaker gravitational force constant, you will get, at best, little stars that don't make interesting stuff like iron and nickel. Basically, they don't make dirt. They don't make planets. They don't make places for biological creatures of any kind to live. A very basic factor is the expansion rate of the universe. How fast is the universe expanding? It turns out if the universe was expanding much faster, if the cosmic stuff was sort of blowing up faster, the balloon was expanding faster, you wouldn't get any galaxies. If the expansion rate was a little bit less than it is, the universe would in fact start contracting before you could make stars, and you would have it implode. It wouldn't be pretty. It wouldn't just oscillate and bounce over and over. It'd just sort of implode. So you've got to have the expansion rate of the universe be just right in order to have a cosmos that can even possibly be a place where living things can exist. The average distance between stars in a particular galaxy and in your particular neighborhood of the galaxy needs to be just right. If you don't, for example, a very simple observation, if the stars are too close, if they're too crowded, then nearby stars are going to destabilize your planetary orbits. As you get too close to a neighboring star, it will pull on your planet, and if it pulls on your planet, guess what? Your planet is going to get too cold. Or, of course, you could have the disaster of stars bumping into each other, and that's never good for the planets in those solar systems. By the way, that's one of the reasons why the universe has to be immense, and why you need an immense cosmos with stars that are very far apart from one another, because if they were significantly closer, you could not have a planet with life sustained over millennia. The nearest star, it takes light over 4 years to get from that star to us. That's a good thing, because if those stars were, let's say, 2 light years away, And there were several of those, and that was the typical situation. And it is in other parts of our own galaxy. But if that was the case where we were, we would be in trouble. We wouldn't be able to live for very long. The Earth's surface gravity. Looking now at the Earth itself, a lot of things about the Earth have to be just right. You've got to have a planet. Not only do you have to have a planet, but it's got to be the right kind of a planet, and it's got to be, a lot of things about this planet have to be just right. For example, the surface gravity needs to be just right, because if the gravity is too strong, you'll get a lot of ammonia and methane in the atmosphere that can never escape the planet's atmosphere. And living things would have a tough time breathing ammonia and methane on a regular basis. If the surface gravity is weaker, you're not going to be able to retain enough water in the atmosphere to have a biosphere that can sustain all the interesting kinds of things living things that we have on the Earth. A very basic, very simple concept in relation to this idea of the Earth needing to be fine-tuned or just right is the Earth's distance from the Sun, from its star. If a planet is too close to the star, it will obviously be too hot. If it is too far from the star, it will obviously be too cold. So there is around every star or not every star, but any star that might possibly be able to sustain an inhabited planet, there is a habitable zone. That the planet has to be, orbiting within that zone on a regular basis. It has to stay in that habitable zone at all times, has to be a very stable orbit, and has to stay within a very narrow band of space around the star that it is orbiting. And so, just because, for example, when a scientist says, we found another star that has a planet orbiting it, that's cool. But it's got to be in the right zone. And you think about it this way. This is an analogy that I use that may, this is a rough analogy, but I think it gives you the general idea. Let's say that you're going to fly over a football field with a dozen ping pong balls, and you're going to fly over this football field in a plane of some kind or a helicopter. And as you come over the football field, you're going to just toss out the ping pong balls over the football field and let them land where they may. Now, you might actually get a few ping pong balls to land on the football field. But what if you had to land that ping pong ball between the 3-yard line and the 4-yard line at the north end of the football field? Well, that would be pretty tough. And you could drop 100 ping pong balls, and maybe even more than that, and have very little chance of getting one to land within that area. Well, that's analogous to the situation of needing to have a planet show up not only around a particular star, but having it show up within that habitable zone. It is a very small region of the solar system that could have such a planet. Well, I could go on and on. I mean, we could talk about the Earth's rotation period, the thickness of the Earth's crust, the carbon dioxide level, the ozone level. I mean, we could go on and on, but the point is made that an awful lot of things need to be just right in order to have a planet that might, I'm not saying that would or that does, but that might have life on it, that could sustain life if you put it there. Back in the 60s, the scientists that were thinking about this, people like Carl Sagan, were saying there were two factors that they recognized needed to be just right, and that is you need the right kind of star, and you need a planet the right distance from the star. You say, well, what difference does it make what kind of a star it is? Well, if it's a very large, red giant type star, if it's a very, very big star, it's not going to work. You're not going to get the kind of stable heating at the right intensity and so forth for very long in order to sustain a planet as a biosphere. If it's some kind of white dwarf or something like that, forget it. You got other problems. It's got to be what scientists describe as a middle-aged star. A middle-aged star would be one that is in its life cycle, about halfway through the life cycle of a star. It needs to be something like our yellow sun. And there are quite a few of those in our galaxy, but they're a minority. They're not by any means the typical run of the mill star that most stars would be. So you got to have the right kind of star. And granted, there's a few of them. There's quite a few of them. But you've also got to have a planet that's got to be the right distance from the star. And those are the two factors that Sagan and others about 50 years ago acknowledged as being critical to the possibility of a planet sustaining life. Well, now the list of such parameters that have to be just right has run up to about 100. And the longer the list gets, the more obvious it is that just way too many things have gone just right for this particular universe. Now, what are the odds, people want to ask? It's very difficult to calculate the right kind of, in any kind of definitive way, the odds that there would be a planet in the universe that has this everything just being right. There are scientists who are Christians and even Christian apologists who will take numbers they're quite defensible, but they're at the sort of extreme range. The least, perhaps in some cases the least optimistic numbers. And you'll find, of course, non-Christian scientists using from their vantage point, the most optimistic numbers of, there could be a planet like that. But even the most optimistic numbers are not optimistic. Even the most optimistic numbers put the odds of any planet anywhere in the universe like this one at something like 1 in a billion. Now, we're not talking about 1 out of every billion stars. We're talking about a chance of 1 out of a billion of any star anywhere in any galaxy in this universe being everything that star needs to be, with a planet that is everything that planet needs to be in order for it to sustain biological life of any interesting kind. Now, the evidence here is so overwhelming that even some agnostics are acknowledging it. Peter Ward and Donald Brownlee are scientists at the University of Washington in Seattle. They came out with a book a number of years ago called Rare Earth. Rare Earth. And in Rare Earth, they took a look at the evidence and they said, you know what? It's possible that there are living things on other planets, but if there are, they're very uninteresting. They're microbes at best, and in fact, even that's not particularly likely. And so we really need to be realistic and say, although it's hypothetically possible that there are other planets with, Vulcans and Klingons or whatever, it's highly unlikely. In fact, it's highly unlikely that there are any other planets anywhere in our galaxy or even in the universe that are like Earth in their potential, not reality, but potential to support biological life. And in their book, they make this statement, which I think is a fascinating statement. If some godlike being could be given the opportunity to plan a sequence of events with the express goal of duplicating our Garden of Eden, and that's their term that they're using, that power would face a formidable task. with the best of intentions, but limited by natural laws and materials, it is unlikely that Earth could ever be truly duplicated. Too many processes in its formation involved sheer luck. Now, these are agnostics now saying this. They're saying even if there was some godlike being out there, he would have a really hard time making a solar system with a planet like ours. There's just too many things he'd have to get just right. Well, my response is, he's absolutely right. A godlike being would not be up to the task. You can't have it done by a godlike being. You need an actual God. You need a real God who's infinite in knowledge, infinite in wisdom, infinite in power. He could do it. But a merely very powerful being, a kind of Zeus-like being, would not be up to the task. So now we can put to bed not only atheism, which denies the existence of a God, and say that's no longer a viable view in the view of the scientific evidence, but we can also dismiss the skeptical argument of David Hume, the Scottish Enlightenment philosopher. David Hume, if you've never heard of him, nevertheless, you live in a culture that has been influenced by him in an unbelievable extent. David Hume argued that even if we thought that the evidence of design in the universe was such that it would have to imply a designer, Hume argued it wouldn't have to be an infinite creator God. It could just be a very smart designer. Well, as Ward and Brownlee in their book Rare Earth admit, even a very, very smart designer, godlike being, would have a tough time doing it. It probably would not be something he could pull off. You really need an infinite creator to do it. So Hume was wrong. A finite God is not a sufficient explanation for the universe. You need an infinite God who transcends the universe, transcends space and time, and who has the infinite power and wisdom and knowledge to pull off the orchestration of the physical events and processes and history of the cosmos to bring about a solar system with a sun like ours and a planet like ours. And I could have gone on and talked about the moon and Jupiter and all these other things that need to be just right in the solar system in order to have a planet that could sustain life. Not that has life, but even could. We haven't even talked about the origins of life here. We're just talking about the origins of the planet that might have life show up on it and survive. All right, so I've run over time with the lecture, but let me just end with a couple of quotations from scientists who are not happy about this, but who grudgingly acknowledge that the evidence is now in, that the universe, if not really being designed, looks that way. Stephen Hawking, quote, "The odds against a universe like ours," notice not just a universe, but a universe like ours, "the odds against a universe like ours emerging out of something like the Big Bang are enormous. I think clearly there are religious implications whenever you start to discuss the origins of the universe," end quote. Fred Hoyle. You remember, Fred Hoyle didn't like the Big Bang Theory, didn't like the idea of a personal creator God. Quote, "A common-sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature." We could go on. I mean, Paul Davies, "The impression of design is overwhelming." Many scientists have made these kinds of statements, grudgingly acknowledging that the universe appears to be designed. All right, so what we see then is that the scientific evidence now has the atheist and the agnostic on the run and on the defensive. It's not that they can't come up with what seem to them to be plausible ways out. I don't think they're plausible, but they do. But they admit now that the universe had a beginning and that it looks like it was begun in a very intentional fashion. and that their job is now to find some way out of that predicament. So the Christian who believes in a creator God, who designed the universe and created it out of nothing, has nothing to be embarrassed about with regards to the scientific evidence. At the very least, we can say the evidence is surprisingly consistent with the Christian theistic worldview, and difficult to square with a materialistic, atheistic worldview. So that it is now the atheist who is on the intellectual defensive and not the Christian. Well, let me stop there and open it up for your comments and questions, and we'll do this for at least 15-20 minutes, and maybe a little longer if there seems to be a lot of good stuff being asked here. So I'm going to get off the microphone, turn it over to our moderators, and you can ask your question either using the microphone or typing out your question, and we'll try to take them one at a time.
John stated that he had heard that in an infinite amount of universes, the one that works would have an apparent sense of fine-tuning. So there must be an infinite amount of universes created at the Big Bang. Here's how Rob replied.
Yeah, this is a very common question because a lot of people are now gravitating to this particular explanation, and that it's based on a particular interpretation of quantum mechanics or quantum theory, which says that there are many universes, in fact, potentially an infinite number of universes, and we happen to be in this one, but there's gazillions of them, and this is often called the many worlds hypothesis. And there are various interpretations of quantum theory. There's maybe a dozen different basic theories as to how to explain quantum theory, or models for understanding quantum theory, and there's no unanimity or consensus or even generally accepted viewpoint in quantum mechanics as to which one of these philosophical models or explanations is the correct one. And so what you have then is this many worlds hypothesis is predicated on a speculative interpretation of a speculative model of quantum theory. Now, is that a really good foundation for denying the obvious, which that the universe appears to be designed? Let me give you an analogy here that may help people see the problem. The argument goes something like this. If you've got enough universes, and they're all a little bit different, one of them is going to be just right and going to have a solar system that's just right and a planet that's just right, and it's going to have life on it, and it's going to have us. We just happen to be in that one in a gazillion universes that happens to have us. But we could easily have had, there could easily be many other universes where we don't exist, and we couldn't exist because the parameters were just a little bit different. But we just happen to be in this one, and there's no reason to think that there's anything planned about our universe, simply because there's all these other universes where there are no people there. Well, if there's a designer or a planner, what did he mess up on those universes? That sounds like a good argument, but first of all, notice there's no evidence being given for these other universes. It's just a what-if scenario. We don't know about these other universes. We don't have any evidence that any other universes exist, let alone gazillions of them. And you need gazillions of them for this analogy to work. If there were 50 other universes, this analogy would not be of any use whatsoever. You need lots of them. And you need something approaching an infinite number of them for this argument to work. You certainly need at least billions of them on a conservative estimate of the facts. So you really need a lot of universes, and potentially you need an infinite number of them. So that's we don't even know if there's one other universe, let alone millions of them, or billions of them, or quadrillions of them. So that's totally speculative. But even if there are quadrillions of other universes, this is not a particularly good argument. Let me explain why. And I will turn around and I will use an analogy. Because the use of analogies is instructive for understanding the argument or picturing something, but it doesn't prove anything. So, for example, the analogy that's often used is the lottery analogy. If you've got millions of people playing the lottery, and you're one of them, and you happen to get the right combination of numbers and win the lottery, it would be a mistake to say somebody planned that I would have the winning ticket. No, you just happened to be the lucky guy that picked the right string of numbers. And if millions of people are playing the lottery, every once in a while somebody wins the lottery. They don't win it every time, by the way. If you live in a state that has a lottery, you've noticed this, that the lottery jackpot goes up and up and up because people don't win the lottery every time. But somebody eventually will win the lottery, and then it goes back down to 2 million or whatever. And so the lottery analogy says, if you've got millions of people playing the lottery and somebody wins, you don't conclude that it was planned that particular person would win. But this analogy has a big problem. That is, it was planned that someone would eventually win because the lottery was set up with a certain set of parameters to ensure that the state would earn some revenue from the lottery by charging everybody $1 for a lottery ticket and setting up the parameters of the lottery so that not everybody or not too many people would win, but that some people would win. In other words, somebody designed the lottery so that somebody would win. That's the first problem with this lottery analogy, and the whole argument is that in a lottery, it is intended that somebody will win once in a while. Because if nobody ever won the lottery, nobody would play. And if too many people won the lottery, the state wouldn't have one because they would go bankrupt. So what they do is they rig the lottery, they arrange the lottery so that somebody wins every once in a while. Just enough to keep everybody else playing. That's what it is. So there is intentionality and planning in the lottery, though not that a specific individual will win, but that somebody will win. But now let me give you another analogy. We can call this the firing squad analogy. Let's say you have been convicted of a crime and you have been sentenced to death by firing squad. You're set up against a wall. You're given your last cigarette. You're blindfolded. 12 guys with rifles aim their rifles at you and fire away. And they all miss. Now, what's your first thought about this after the blindfold is removed and you're told that today's your lucky day and you're free? Your first guess is somebody told those guys to miss on purpose. Because 12 guys with rifles can't all miss me at point blank range, at 20 yards or something. So apparently somebody, maybe the warden or somebody, the governor, who knows? Somebody arranged that they would all miss and I would go free. So there was intentionality there. Now somebody comes along, our atheist comes along and says, "Oh, that's an unacceptable explanation. Maybe all of their rifles misfired." Now, you look at the odds of that, and rifles do misfire, but the odds of 12 rifles all happening to misfire on the same occasion is astronomical. So the atheist says, well, in the history of humanity, we have had a lot of firing squads. I mean, who knows how many firing squads have there been in the history of mankind? Probably thousands or millions of firing squads. And it's quite conceivable that let's say there have been a million occasions on which firing squads have shot at a prisoner. Surely it's possible that on one of those millions of occasions, that all 12 of the riflemen would all miss the target on the same occasion. Now, almost anything is possible, but if you're the lucky guy, you are not going to believe that the 12 guys just happened to be that one group of 12 firing squad soldiers who all happened to miss. You're going to be convinced somebody likes you. And I guarantee that if you are convicted of murder and the victim's family hear that you got away, they are not going to believe that it was an accident. They are going to believe that somebody intended to let you go. So I'm spending a little bit of time on this because I want people to really get an understanding of this whole argument. Even if there are gazillions of universes, the evidence that this one was designed and that this Earth was designed and fine-tuned to make it possible to sustain life is still good evidence. Just as, even if there have been a million firing squads in history, the fact that 12 guys all miss at 20 yards is still strong evidence that there was some intentionality behind that surprising event. And so the many worlds hypothesis, even if you allow that there are many worlds, which again there is no evidence of that, does not disprove or discount the evidence that this one was designed to make it possible for us to live here.
Sean asked a question regarding dark matter. Here's how Rob responded.
Hi, the question is about dark matter and the current status of the whole controversy over dark matter and how this might pertain to an oscillating universe theory. I don't know that I can answer that off the top of my head. I do know that there is a continuing debate over so-called dark matter. I don't think anything has been definitively settled in the minds of all cosmologists or astronomers. But regardless of how one addresses this particular issue, and it's too technical for me to be able to explain off the top of my head here, the general consensus seems to be that it has to do with how much of the universe is composed of this so-called dark matter, as opposed to other kinds of material in the universe that we would associate with stars that we can see with the naked eye or with telescopes or what have you. And depending on how much of the universe is dark matter versus how much of it is not, you have different models of the Big Bang. Well, regardless of how one answers that question, it doesn't look good for the oscillating universe theory, because that's not the only problem facing that particular hypothesis. So, again, the oscillating universe theory, there is a very small minority of astronomers and cosmologists who are hoping that something like that can still be vindicated, that the evidence can be turned around in favor of that view. Most of them have given up on that. They have concluded that the universe, had one beginning and is expanding, and it's not going to contract. If I can, this may be a simplification, but I'll hazard this simplification. There are theorists who are hoping that the universe has a lot more matter in it, a lot more stuff in it, than what we can see. And if there's a lot, and where you would get this would be this so-called dark matter that cannot be seen with a regular telescope. And if the universe has a lot more matter, I mean a lot more, than what it appears to have, then it is hypothetically possible, according to these scientists, that there is so much matter that gravity will eventually take over and slow down the expansion of the universe to nothing and then start making it contract again. If that happens, according to these scientists, then you could have an oscillating effect. Well, whether there's enough dark matter in the universe to make that possible or not is still being debated, but even if there was enough dark matter to make that viable on that level, there's still a lot of other problems. There's still the distribution of the radiation, of the cosmic background radiation. There's other problems that really, in most scientists' mind, the leading scientists in the field, we're not talking about evangelicals who are, just apologetically motivated. People like Hawking and others who are definitely not Christians, don't like Christianity, are not believers in God. Most of the leading scientists in this field have concluded for a number of years now that the oscillating universe theory is not a viable explanation of the nature of the cosmos.
I asked a question regarding the issue of infinite regress into the past and how that is somewhat problematic for the oscillating universe theory. Here's how Rob replied.
Well, Carrie, you're right. You would still have that question of if you want to hold to an oscillating universe theory in order to sustain the idea of an infinitely old universe, you would have to have you would have to deal with this problem of an infinite regress. Now, there are two ways out of this. One is to simply observe that this is a philosophical problem, not a scientific problem. And there are philosophers who try to argue for the cogency or plausibility of an infinite regress. And of course, there are philosophers who argue against the idea of an infinite regress. And for those of you who are wondering what an infinite regress is, and if this has anything to do with, some kind of strange animal or something, the idea of an infinite regress is the idea of going backwards into the past and never arriving at any kind of a stopping point, and you just keep seeing the same phenomena perhaps appearing over and over in some kind of cyclical view of the cosmic history. How can that be that there is no stopping point to this going back and further into the past? And so this idea of an infinite regress is problematic. It's the question of, what caused, the universe to come into existence? Well, it was something else than God. Okay, so what was that thing? Well, whatever we speculate it might be, what caused that thing? And then you keep going back. And don't you eventually have to arrive at something that doesn't need to be caused? And that's kind of the one way of looking at the philosophical problem of an infinite regress. And there are people who will argue, well, that's just a philosophical issue, and I'm not dealing with that. I'm dealing with the scientific possibility of an infinite regress. And then the other thing that they could say is, well, I don't need it to be infinite. I just need there to be a lot of big bangs and a lot of universes, a lot of oscillations. Because if you have the universe oscillating back and forth, expanding, contracting, expanding, contracting, expanding, contracting. And if you have it happen a few million times, it's not infinite, but a few million times, it begins to seem more plausible, at least emotionally or psychologically more plausible than in one of those expansion phases, that the expansion would be just right to sustain life. And so this is now kind of a modified and moderate form of the oscillating universe theory, which maintains it's not eternal, it's not everlastingly oscillating, it hasn't always been oscillating. There was an original Big Bang, perhaps, millions of oscillations ago. We happen to be in oscillation 1,242,964, and that happens to be a really good oscillation where the conditions were just right for the Earth to form and for us to be here. Now, this version of the oscillating universe theory gets around the many worlds problem by saying, no, there's only one world, but it's been expanding and contracting, for, however many, thousands or millions of times, and we just happen to be in the lucky oscillation that includes us. And I think that the firing squad problem applies to this explanation as much as it does to the many worlds theory. Now, again, philosophers like William Lane Craig argued that the idea of an infinite regress is philosophically untenable. That's a different question. You get into the philosophy of religion discussions and philosophical apologetics, then you can look at that particular argument, and there are philosophers that endorse Craig's objection to an infinite regress, and there are philosophers that argue against it. But in any case, Bill Craig would acknowledge that's a philosophical argument, which he then supplements with the scientific evidence that whatever you may think is philosophically possible or plausible, the physical evidence actually shows that the universe had a beginning and that it is not an oscillating universe, but it's simply going to continue expanding until it's, forever, as far as we can tell, or until everything comes to a grinding halt. So that would be a brief answer to this particular question about the infinite regress.
And finally, a student in the class asked Rob's opinion of the documentary Expelled. Here's how Rob responded.
Well, I saw Expelled, and there were some things about it I really liked, and I overall I wasn't happy with the way it was done. It was a little on the cheesy side, and there were some. Let's put it this way: it was a popularization of intelligent design, and it was popularized to such an extent of sort of bringing it down that it left the ID movement wide open for criticism, because the arguments were presented in such a kind of sloppy or simplistic fashion. So I'm not a big fan of the documentary. I'm not a critic of it, and since I wouldn't discourage people from seeing it or suggest that it's a bad film, but you have to take it for what it is. It's provocative. It's attention getting, and that's all for the good, because we want people to pay attention, and so I think it would be fine to take a look at that. But just be aware of the fact that it's a very controversial film, that its goal is really to popularize and kind of wake people up and get them to be thinking about this, not so much to introduce all the issues in a sober, academic way. The hot controversial claims of the film would be things like, that there is a concerted effort to keep creationists and intelligent design theorists out of academia, out of research scholarship, scientific in the scientific community. There is some evidence to support that. There's no question. And of course, there's the other big controversial claim of the film, and that is that evolutionary theory, Darwinian evolutionary theory, has some kind of association with, contributed in some way to the Holocaust. And that's a very inflammatory claim from the standpoint of people that believe in evolution. But whether there is a philosophical connection or not is should be an historical question. It shouldn't be an ideological war. But that's what it is, because people who defend evolution are very offended by that argument, and that's worth looking at. That's worth examining, and the evidence for it should be examined. But so I think the film has some merit as far as getting people to start thinking about these issues. I wouldn't look to it as the best source of information on the subject matter.